Okay, I'm handing over the session host job to Max from Gina AI, and without any further.
Thanks, and I'm looking forward to a really interesting talk where Alberto will talk about more evaluation and include cross-encoders. We haven't heard too much about cross-encoders today yet, so very curious.
Hello. Yeah, so welcome to my talk about offline evaluation of product search with model-based judgments, which somewhat related to what things that were discussed before. My name is Alberto. I'm a senior ML engineer at Shopify. For those of you that don't know about Shopify, it's the largest commerce platform in the world, serving millions of merchants. And yeah, fun fact, we just crossed 1 trillion in GMV last week, so it's a nice milestone. So the agenda for today is that first I want to give a quick overview on search use cases that we have at Shopify. Since I work in the Search Foundations team, we have a little bit of different use cases. Although the main topic for today will be about product search. Then we will go into the problem statement, why am I here, and then which solution are we applying to that problem, which, spoiler alert, is about model-based judgments. And then we will go into how you can, after this talk, you can go back to your PMs and tell, I want to build a binary judgment model. This is how we can do it. And then we will finish with some conclusions. So about search at Shopify, right now, I'm mostly working in this space, which is the shop marketplace. And especially the search issue is about product search. The shop marketplace is a B2C marketplace that we have for Shopify merchants. It's a marketplace that has hundreds of millions of products in their catalog. And it has two main surfaces, like the web UI you see in the left, and then the shop app, which is the main surface. But there are also other search use cases, like for instance, the storefront. For all those millions of merchants that are in Shopify, we also support, if they want to, their online search experience and everything related to their discovery experience. This is one example of Mr. Maple, which is a Canadian merchant selling flowers online. But then there are other search use cases like the search admin basically a merchant, this is how they operate their stores there. So they need search, and also in the ecosystem, we have apps. So we allow merchants to find and discover those apps through search. But yeah, as I mentioned, the shop marketplace is the main use case for what we are going to talk. So regarding product search, one thing that is very important and was already discussed here before is around offline evaluation. So in general, why do we need offline evaluation? So it helps you release with more confidence. Like even if you have even if you're going to run an A/B test, you need to somewhat qualify the variant that you're going to run, because you just don't want to put whatever the latest data scientists came up with without any even manual testing. And the second reason is that you want faster iteration cycles. If you need to wait for an A/B test to finish, then you will move much slower. And even if you have the traffic to run an A/B test fast, probably it's a good idea also to leave them running for at least some kind of like a week or so to account for seasonality and other patterns that might affect the user behavior. Specifically, how we've been doing offline evaluation in this marketplace was with implicit judgments that were discussed also in previous talks, based on click-through rate and other implicit feedback coming from logs. But the thing is that we found that it's not good enough for our use case. So the first issue that we have here is judgments scarcity. So as I mentioned, it's hundreds of millions of products in our catalog, and it's impossible that we will cover a lot of the queries and a lot of the products and the new products that are coming in with judgments. So that's a big issue. Then the bias, like presentation position bias associated with those logs, and also the noise, like I think Roman mentioned before, like if you only have one click or one impression, are you confident about those CTRs? Even if you apply like a Bayesian correction on top, is still, I think, not good enough. And other things is that the search or the search that you reinforce to this type of offline evaluation might not be aligned with the desired UX. And we will talk about a few examples of this. So to illustrate the click-through rate scarcity issue, let's take an example here. So for instance, let's imagine that you are running your offline evaluation against a set of golden queries that you want to do. You take one query, let's say, for instance, Nike, and you run your new fancy new algorithm, and you evaluate like top results. So let's imagine these are the top 5 results that you get back. And let's imagine that we have 3 of those products that have, you have some sort of confidence in their judgments based on click-through rate, past click-through rate, and maybe a correction on top based on a Bayesian model. But then you have 2 products that you brought up, but you don't have any idea of how those products work. A typical assumption is to just say the judgments for those products is 0, or you fall back to the mean. Let's imagine those products are actually really good products. So what you are doing here is saying, if you are saying that are 0, then your offline model will never try to put them there. If you say they are the mean, it's also the same. Like you are still pushing all products to the top. So basically, if you, that means that an offline evaluation based on this will try to keep reinforcing the good all products that you already saw. And therefore, like if you add a new retrieval arm, like could be in these days dense retrieval, which tend to bring more diversity than just lexical search, it will start, basically your offline evaluation will tell you just follow the lexical that you were having, that you were using before, pretty much. Then regarding UX impact, I think previous people talk about this issue. So let's imagine the user is searching for an iPhone and we are returning iPhone cases. So are the iPhone cases relevant to the query? You could say, yes, they are relevant, but is it, might be the user confused by what you are showing at the top iPhone cases? Yes, that could also happen. They might be questioning, do they even have iPhones here? So one thing that we want to improve in our experience is to be more precise in what we return, and maybe prompt the user to reformulate the query, or we just give them, maybe you are searching for something like this. And if we stick with this explicit judgments, one of the issues with implicit judgments is that these products, they do have clicks because users click in random stuff. So yeah, this will keep reinforcing the iPhone cases as a good thing for, for this type of query. So as mentioned in the title, the solution is model-based judgments. So yeah, you could spend a lot of time trying to denoise your implicit data and try to correct for bias on presentation and position. But let's just use a model to generate judgments for you. Of course, we all when showing this meme, we all think we are on the right side, but yeah, that's another question. So how are we framing this problem at Shopify internally? So we frame the judgments generation into 2 tasks. The first task is about binary relevance, which is answering the question, is this product relevant for given this query? Yes or no? And that is what powers our precision and recall metrics. And yeah, we can also calculate NDCG on this binary metric, but it's not going to give us like a lot there, and will be mostly correlated with precision. And the other task that we think is, okay, once we know that this set of products that we are returning are actually relevant for the query, are we putting the right products at top? That's the other ranking task that we are working on. So for the first task, we already have a model that we are using in production to offline test or search. And the second one, we are working on it. So I will not talk about that in this presentation. Yeah, so now that once you go back to your home, how can you build a binary judgment model for your use case? So the first thing that you should work on is to build your model and data flywheel. For those of you that are ML engineers, you probably already know this, but I think it's also always a good idea to remind about this. First thing that you need to do is to collect your golden evaluation data set. That is, how are you going to evaluate that your model is doing the thing that you wanted to do? And here, pay attention to the how representative is the sample that you are collecting with the product objectives in mind, or the business objectives in mind. You might think that spending 3 days annotating data is not a good idea, but it definitely is, and it will help you ship these models with more confidence and faster down the road. We did it internally, and yeah, I think it's a good practice. And then you set up your training loop, you prepare a training data model, and then you start getting the initial model metrics and error analysis that will allow you to go back upstream and improve your training data set and also your model. In terms of like, if you want to start building your own model, what data can you use? Initially, we use the public data set called the ESCI from Amazon Search, which stands for exact, substitute, complementary, and inexact products. And it contains 2 million query products that are annotated for relevance. And we saw it translate well, like relatively well, to our problem after some preprocessing of building the right certification and so on and so forth. You can also try to bootstrap your model with some synthetic data, like for instance, GPT-4 is not great at this task, but is better than nothing. So you could try to distill GPT-4 at least initially, but yeah, it will put a cap into the type of metrics that you can achieve. Other things that we tried is to use positive real data, like for instance, query products that have converted in the search, and then ask GPT to generate negative queries. An example of this type of prompt is in the slide, where you say, for instance, let's imagine that you have a product that is Jordan's sneakers, and that the query that led to that conversion was Nike. So you prompt GPT to say, generate a similar query, yet inexact, and in a similar structure at exact query. And GPT, although might not be great at classification, is good at generative tasks. So this is also another alternative. The one that we are currently using is manual annotation. If you have the resources, will give you the best data, but that comes at an operational cost. And you need to train labelers and all those things. Depends on the resources. But even if you, as we will see, manual annotation is also, if you are small team, you could also do it. We'll talk more about this later. So in terms of what models are we actually using? So we tested 2 approaches. The first one is using LLM as a judge, which is a typical framework also like to test generative task, but in this case, we applied it as a disclassification task, and also build a specific classifier as a judge. In terms of LLMs, like you could do just like Llama 3, which is the nice kid in the neighborhood. Yeah, just the 8 billion extract, those models, they will not be good enough. You can test them, but they are not going to perform well. If you go with an LLM of 7 billion, 8 billion, like Mistral, Llama, etc., you need to fine tune it. We check that with a few hundred samples, you can get reasonable performance, and you can use a prompt similar like this. Like you just frame the problem that you want to do. You ask it to tag a pair of query and product as E exact match or I inexact match, depending on whether the product fully satisfies or matches the intent of the query. And then you can pass like the query like Nike, and then a product passage that describes the actual product, and you say, okay, give me the response. For this classification task, it's usually a good idea to just use one token as the answer, because yeah, then inference will be much faster. You only need to generate one token. Yeah. In terms of specific models, yeah, I think it was discussed already, but we are using a cross-encoder, or at least a version of a cross-encoder. So you might be familiar with bioencoders because they are generally used for yeah, dense retriever. The bioencoder or two-tower model, you tokenize, basically you embed the product passage at index time, and then at query time you embed the query, and you do dot product or cosine similarity to get a score. And this is good for retrieval. But then the cross-encoder, which is typically used nowadays for ranking, is how it works is that you only have one tower, and then you tokenize together the query together with some separation tokens and the product passage. And what happens here is that the encoder model actually can learn better interactions between the query and the product due to the attention mechanism that happened here. So cross-encoders are more precise, but usually they are more heavy on the inference side. But we end up building in the end something like this. This is the architecture that we have right now in production, which is like the text cross-encoder, as I mentioned before, and then some clip embeddings at the side based on the clip text encoder, text embedding of the query, and the clip image embedding of the product image, and with a classification head on top. This is what we use right now in production. So in terms of performance summary, so Llama 3, just the instruct model out of the box, doesn't require much data because you just do a few shot prompting, but the classification performance is really low. Then Llama 3, 8 billion LoRa fine-tune. You can fine-tune a reasonable good model with a few hundred samples, but the inference cost at 1 million pairs goes around $200, and then depending on quantitization and other details that you can optimize for, and the classification performance is high. Cross-encoders, we've trained them even better models than Llama with just 1,000 samples. So if you manually annotate 1,000 samples, you can get reasonable performance, and the inference cost is orders of magnitude lower than what you have with an LLM. And yeah, latest experiments we have is the best performing model. There is also one paper that I can share later where just Roberta beats LLMs, even fine-tune, even these days. So how do we use this model to do evaluation? So let's imagine now we have a new search algorithm that we are going to test. And we have our golden set of queries that we typically run our offline evaluation on. And let's imagine the knives query is part of that set. So let's imagine that for this strategy, the first 4 products are just knife mats, which is not what we want to put at the top. We do really care about the precision of our search, and even if it's somewhat related, we say no, this is not it. So how this will turn out. So, okay, precision at 1 will be 0, precision at 4 will still be 0, precision at 8 will be 3 out of 8, because only 3 of these products are actually knives. Of course, you can see this being aggregated into multiple queries and look at distributions, get summary statistics, and with that you can make a decision on whether your search strategy is good or not. Then we also use it to, I think it's also very important when you build search systems to actually look at the results, not only rely on metrics. So how do we use this model is to, okay, let's calculate precision at 1 for the set of queries. And we have two strategies, one that we call Elasticsearch multi-match, the other one we call Elasticsearch basic. Let's look at queries where the new approach improves over the old approach, let's say that way. And we sample a few examples. In this case, we get e-bike as the query, and the first approach, actually returns e-bike at the top, while the other approach returns e-bike cranks. Note that both products have a title match on the query, but the model tells you no, the one on the left is actually an e-bike, which is what you're looking for, and the other product is not an e-bike; it's just some accessories for the e-bike. So conclusions about this. Model-based judgments are a great way to avoid all the position presentation bias that you can have on your data, but especially they are really good at filling the blanks. Like as we see, like implicit judgments have a lot of sparsity, and different type of products have different confidence because it depends on how many times that product was seen. So model-based judgments for the win. Specialized models right now are better than LLMs. I think this is for now. As the cost of LLM inference goes down and the improvements on LLMs go up, that might change. But for now, they are better. And data is key. Make sure you have great golden evaluation data sets to build these models, and keep iterating later on the training data. So that's it. Thank you very much. And I can answer some of your questions. We are also hiring across engineering, data, and product. So if you have any questions, you can reach out.
Thanks a lot, Alberto. We have time for some questions.
I saw before you do a cross-encoder with product text. Would you also include like images or some information, other information about the product?
Yeah, we use right now clip embeddings for the image, but we will extend also the architecture to account for other structured data, because right now text is purely unstructured, and both images are both unstructured. But we will add more. Like price is also an important signal. Like you don't see an iPhone for $20. So
I would like to take the opportunity to directly ask a question. So for the clip model, did you try multiple ones or just the standard model, some from OpenAI?
We are going to test more, but right now this is like the basic from OpenAI. But we like, I think, oh, you are from Gina, right? Yeah, so okay, I get it now. We share your model internally. We are going to test it, but also from Mixed. I think they also released a new one. So last week was clip week. We will test a few of them.
I would be curious because in text we know that different models have very different performances on different tasks, and so I think for images that might be the same. And also there are traditionally more than one clip model. So that's why I'm curious. Not just for our in general. More questions?
Thank you for the talk. Very curious, you mentioned building the golden set. You gave the good tip that spending a few days annotating is not wasted time, but you warned that it should be representative. How do you go making sure that the things I made over 3 days are actually representative of what my users will end up searching for?
Sorry, can you repeat the question?
How do you make sure that your golden data set is representative? What is your approach to having more certitude that the things you annotate manually are representative of your user base, especially if it's a diverse user base?
Yeah, so I think there are a couple of approaches that you can take. You can take a sample based on traffic, the typical queries that you get, and then get some of your retriever arms to pull some data, and then sample even from those. Other approach that also we are thinking is like our current traffic might not represent what we want to go in the future. So we might over-index on, let's say, searches that search, for instance, in the marketplace example, brand searches, category searches, those type of searches, we might want to over-index in those cases. I think it's a product decision there. Yeah.
Well, if not, then thanks a lot again.
Cool.